All right, the last part of 12.1 is our special right triangles. And we have two special right triangles. We have our 30, 60, 90, and then our 45, 45, 90. Hopefully you remember these from geometry. If not, we are going to do a refresher. These triangles are super important, especially if you're going to take trig next year or you plan on taking calc in the future. They're going to expect you to know these really well. So make sure you are looking through them. We're going to go over how to find sine, cosine, tangent, cosecant, secant, and cotangent in the future. Right now, we really want to focus on being able to solve a special right triangle. These ones, if you're asked to give exact answers, you need to use the formulas. Also, they would typically be on the no calculator part of the test. Okay, so if we look at our 30, 60, 90, this triangle on the left side, separate these. We have the three angles and then the three sides. When I taught this last year, I taught that the side across from 30, which are short leg, and I always labeled that SL, capital letters so it doesn't look like a 1 or anything else. And then the other leg would be the long leg, which I labeled LL. And then again, we have our hypotenuse, which is just HYP. So for a 30, 60, 90 triangle, there are two equations technically that you want to have. And knowing the 1, 2, and the square root of 3, that's going to be very helpful. So we would have our hypotenuse is equal to your short leg times 2. And then the second equation you need to know is that your long leg is equal to your short leg times the square root of 3. So we have 1, 2, square root of 3 on this triangle. Then our 45, 45, 90 triangle on the right side, because the two angles here are the same, that means the two legs are also equal. So if you know one of the legs, you can find the other leg. And then we have our hypotenuse. So leg, leg, and hypotenuse. For this triangle, all you need to remember is that other than the legs are equal, that the leg being multiplied by the square root of 2 is going to be equal to our hypotenuse length. Okay, so using that information, we're going to do example 5. They want us to find the missing side lengths of x and y. So looking at this triangle, right away, I recognize that it's a 30, 60, 90. So I'm going to write down my two equations because you are going to need both of them right away. Okay, so in this one, the hypotenuse I know is x, so I'm going to replace the hypotenuse with x. And then the short leg would be across from the 30-degree angle, which is over here. So my y would be my short leg. So I'm going to replace that with y, and then times 2. This one has two variables, so I can't solve it right away. So then I'm going to go to my other one. I know short leg again is y. And then we have times the square root of 3. Then we need our long leg, which in this one would be 9, or across from the 60-degree angle. This equation only has one variable, so I can solve for that one right away. When you have a radical in the denominator, you do need to rationalize your number. And to rationalize it, you multiply both the top and the bottom by that square root. So this would be a 9 square roots of 3 over, and when you multiply two square roots together, you multiply those numbers. So 3 times 3 is 9. And the square root of 9 is 3. So we would have 9 square roots of 3 over 3. Don't forget to continue simplifying when possible. So 9 divided by 3 is 3 square roots of 3. And that is my y value. So then I can use that to find my other number. So x is going to equal my y value of 3 square roots of 3 times 2. And because the 2 does not have a square root with it, we're going to multiply it by the coefficient or the number in front of the radical sign. So we would have x equals 6, I wrote that twice, square root of 3. And that's your answer. So that's how one way you can use the two equations to find the three sides of your special right triangle. All right. So then our last one, we have a 45, 45, 90. So I know x and y are going to be equal. So if I find one of them, I know both of them. The only equation for that one is your hypotenuse equals whatever your leg is times the square root of 2. So my hypotenuse was the square root of 11, and I'm going to use x for my leg times the square root of 2. So I'm going to simplify. So I have square root of 11 over square root of 2. And then we need to rationalize. On the top, I can multiply the two numbers together because they're both under a square root. And the square root of 2 times the square root of 2 would be the square root of 4, which I know simplifies to 2. This cannot be simplified further because the number on top is under a square root and the number on the bottom is not. So you just leave it as the square root of 22 over 2. And that's everything for 12.1. Let me know if you have questions.